Alright, so in this video, I'm going to solve the equation 5 to the power of x is equal to 50. So to solve this, I want to find the value of x. So to do that, I'm going to first start by taking the log on both sides. So I get log of 5 to the power of x is equal to log of 50. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 5 to the power of x, so I can move x to the front, so I get x times log 5 is equal to log 50. Now from here, I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to log 50 over log 5. Now I'm going to rewrite this as log of 10 times 5 over log of 5. And if I have something in the form log a times b, this is equal to log a plus log b. So this turns into x is equal to log of 10 plus log of 5, and I have this over log of 5. So now this is equal to log 10 over log 5 plus log 5 over log 5. So then this turns into 1 plus log 10 over log 5. Now log 10 is equal to 1, so I get x equals 1 plus 1 over log 5. And 1 over log 5 is equal to 1.4306. So I get x equals 1 plus 1.4306, which is 2.4306. So this is my answer. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this and rewriting 25 as 24 plus 1 is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2, and I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4,096 squared is really hard to calculate by itself. So if we change it to 4,000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4,000 and b is 96. So this turns into 4,000 squared plus 2 times 4,000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4,000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.